Hello friends, so in this video I'm going to take you through everything you need to know about the open source OpenAI CLIP model. I'll teach you everything you need to know about this model and how to use it in your personal code. This model is a very powerful model, and a good thing about this model is that it's open source. OpenAI have released this model for everyone to use. So fasten your belt, grab a cup of coffee, and let's explore this model together. So right from scratch, we'll start off from their GitHub repo to learn a little bit about the model and its capabilities. So CLIP, the word CLIP, which is an abbreviation for Contrastive Language Image Pre-training, is a neural network trained on variety of image and text pairs. So guys, take note of this image and their text pairs. So what this means is that this model understand both images and text by associating them in a shared embedding space. So for instance, when you give this model an image of a dog and you've also written and fed it with a text, say let's say this text is a dog, the output embedding this model will give you will be kind of the same because this model associate both the image and the text in the shared embedding space. And this is something great about this model. Okay, so it can be instructed in natural language to predict the most relevant text snippets given an image without directly optimizing for the task. Okay, so guys, you can read this out, but what I want you to know is that you can take an image and a text pairs, and this model understand this image and text pairs by associating them in a shared embedding space. Okay, so I will share the GitHub repo in the description. You guys can read a lot about how to install and whatever, but I'll also teach you how to install this and run this on your local machine. Whether you have CPU or GPU, you'll be able to run this model because it supports both CPU and GPU. They've also provided you a sample code, but I've written a more organized code I'll share with you guys. Okay, so let's quickly go through the code and I'll teach you how everything works. All right, so back to my Visual Studio Code. In order to use this model, we have some packages you need to install, and I've quickly placed all these packages in my requirement.txt files. So inside here, you need to install Touch Vision, Touch Audio, and OPCV headless, and you have to clone the particular GitHub repo for the clip model. Okay, so these are the requirements you need, and I'll make sure this code will be on my GitHub. So you need it, you just have to go there, clone this, and use for free. All right, so let's get back to the code. So this model allows you to do three different things, right? And I'll take you through all the code I've written step by step so that you understand. So on the line here, right after importing these dependencies, on the line here, what I'm doing is that I'm checking if I have GPU. If not, I'll go with a CPU. So we are using touch for that. So device is CUDA, which stands for your GPU. If touch the CUDA is available, that's if you are having the GPU available on your system and it's configured. Else you are going with a CPU. I am going with a CPU because I have no GPU available. But remember, with GPU, you enjoy faster speed, and that's the benefit, right? Okay. Right after that, now we need to instantiate this model. So this model gives you two functions. So it gives you the model and the pre-processing pipeline. Okay, so it gives you the model and the pre-processing pipeline. So you can use this pre-processing pipeline to pre-process your image or text before converting them into the shared embedding. So we do clip.load, and right here we pass in the model type we want to use, and we associate device is equal to device. But before we continue, let me teach you something, or let me give you some gist. Maybe you don't want to use this model. You can check for all the available models they've released right from their GitHub repo. So over here, when you scroll to the down, you can just do clip.available models, and this will return all the available models they have so that you can choose from any of them you want to use. Okay, so maybe you can put that in our code and paste it right here, and then we will print it so that we'll see all the available model. So I'll wrap this in a print statement and I'll run it. But before I run it, let me comment these codes and I'll just give it a run to see. All right, guys, so you can see they have different models, RN50, RN101, and so on. So we are using this particular one. I think it's 32. So let me go forward and see which one we are using. Yeah, so we are using the VIT-B32, which is this one. So you can use any of these models. You can just type any of these names there, and it's going to uh download the pre-trained model for you. Okay, so we are using this particular one, and for now I'll comment this because it also takes a time to run. Okay, so we are using this one. You can just change the name by using any of them you want. And then over here we are giving device is equal to device, so we are just giving this CPU or GPU we are setting up to the model to use. So if it's CPU, it will use the CPU. If it's GPU which is available, it will also use the GPU. Okay, I'm going to teach you the three functionality of this model and what you can achieve with it. So the first thing is that you can give this model an image and it will convert this image into embeddings. Okay, so embedding is like a numerical representation of image. Okay, so when you give it an image, you convert this image into an embedding for you, and then you can achieve a lot with this embedding, right? So you can save this embedding into, let's say, vector database, and right on it you can build applications where you can ask questions on images. Okay, you can ask questions on images. So let's say you want to build applications where you want to chat with uh your image files, right? You can just convert this to embedding, save it in the vector store, and you can retrieve it and ask questions on them. Combining this with large language models, the benefits are just enormous. The capabilities are just enormous. So there is a lot you can achieve with it. So let's go through the code. So this is a function I'm defining called images, and in here I just give it an image. And the first thing I have to do is to pre-process image. So you can see we are getting the pre-processing pipeline right from the model. Okay, so OpenAI is giving us this pre-processing pipeline for free. You don't have to write it. So we just give this image to the pre-processing pipeline, and then we unsqueeze it to add some dimension to it, and we move it onto the device. So if it's GPU, this will just make this whole process faster. So we move it to the device, and then now that we've pre-processed this model, the next step is to encode it. And since we are not doing anything prior to training, we have to make sure we detach our gradient. Okay, so that's why we are saying with touch.nograd. If you are familiar with PyTorch, you know, you understand this already. Then over here we encode this, and then we give it out the processed image. Okay, so we do model the encode, and then we send in our processed image and return our embedding. So this all this function is doing, and we can test this function out right here. So images, you send it to your image, and then it returns you the image embeddings. So I can call this function right here and feed it an example image, and then let's see the embeddings. So I think this is the code for it. So over here I'm reading the image I want to use, and this is the image I'm using. So image of a guy who is smiling. He is very happy and he's smiling. After all, we are living in a happy world, so he has all the right and liberty to smile. So I'm reading this image in, and then I'm resizing it. I'm using the pillow library to read in. So you can see right from pillow, I'm importing image, and that's what is allowing us to perform this function. Reading the image, resize the image to this particular shape, and then we feed this resize image into our image function we've defined at the top here. Okay, and over here we are returning the results because we know this function right here will return us the image embeddings. So for the rule of thumb, in order to know this is working, I'm printing this result out, and if everything works successfully, this should return me the embeddings. Okay, so I'll just quickly run this and let's see what happens. So you can see how it has converted the image into embeddings. Okay, so this is for one image. This is a two-dimensional tensor, and you can see how long it is. So you can see this is the embedding that converted the image to embedding, and this is working greatly. So if you can achieve this, you can just connect this to a vector database, and the possibilities from there is enormous. You can build applications which involves you chatting with images. Okay, so this works, guys. This is working, and this is how easy you can set it up. It's just straightforward. You don't have to write a lot of code. Okay, so I will comment this out and show you the next thing you can achieve with this model. So that's the next function. And this next function is just like tokenization. You token your tests and then encode these tests and convert them to test embedding. So I've covered how to tokenize tests using PyTorch. I've also covered how to convert tests to embeddings using PyTorch. And these tutorials are on the channel. They are in the ML data science playlist. You guys can also check them out. So that's the same thing they are doing. So I'm giving this function the test and I'm instructing it that the type is a string. So you have to make sure the test you are giving is a string. And right from here, I'm tokenize the test. So the clip have a method called tokenize, which takes the test and it will tokenize the test. So tokenization just means you are separating this test into different chunks. Okay. Okay, so that's what tokenization do for you. And then right from there, we are also giving it to the device. So if it's GPU, in order to accelerate the speed, we are detaching our gradient, and right after tokenization, we are giving this test to our model. So model do encode test and giving the tokenized test. You are not giving it this straight test, you are giving it a tokenized test. Okay. And this will also return you with the test embedding. So you can go ahead and test this one too out. So right from there, I can call my function test and give it some tests. So the test right here is coding is fun, which you can just put any test you want to convert to embeddings, and this is going to work. I'm saving this in results because it's going to return me something and I'm printing it out. So we can also run this. Alrighty, so you can see it has also went ahead to tokenize the test and then converted it to embeddings, and this is just great. So if you guys should just remember that what it associates both the text and image in the shared embedding space. Okay, so if the text is about a text of a dog and the image is also an image of a dog, then we are expecting these embeddings to be what, similar. Okay, so that's one thing you should take note of. All right, so I'll take you through the last thing, which is the most powerful aspect of this model. Okay, so this is the most powerful aspect of the model, and this is what unlocks several opportunities for you to build applications with this model. Okay, so that is the last function, and this is where this model shines, guys. I'm not exaggerating on this, but this is where this model shines. So this model allows you to compare both images and text. Okay, you can give this model both image and a text, and then it's going to return to you how similar they are or how far they are from each other. All right, so you give it a given text and an image. So I call this function compare, and it's taking an image and a text. Okay, so right after taking the image, we go ahead and pre-process this image just as we did before. The same thing applies to the test. We go ahead and tokenize this test and give it out to the device. With that, we go ahead to detach our gradient because we are testing, we are using the model. And right here, we are giving both the image and the text to the model for the model to return to us the probability. Okay, so that's all we are doing. We are right here, we are just converting it to numpy, and we are putting it on the CPU because numpy works only with the CPU. So at the end of the day, it will return to us our probability, and that's what we are interested in. Okay, so it's going to tell us how similar the image and the text you are giving it are. Okay, so this is very powerful. Let's test this out. So right here, what I'll do is that I will comment this, and then I'll give you the image of the guy which we are reading here initially. Okay, so we read the image and we resize it, and I'll call this function here and give it the image. So the image is this image that we are reading, and the text here is some array of text. So you can give it an array of text, not necessarily a single text. So we are giving it this image, and we are saying, okay, is this image a dog, is it a person, or a man, or even a cat? Okay, so when you run this, you will see it will associate this with probabilities. Then you can see how this model is working great to identify this as a person. So first I'm printing the text, okay, so that we can use it to compare here. And these are the probabilities. So the image you have given, is it a dog? And you can see the probability that's associated with 0.026. That means it's not sure it's a dog. Is it a person? And it's associating this with a probability of 73, 0.73, okay, closer to 1, which is great because it's an image of a person. Is he a man? And you can see because it's an image of a person, probably could be a man or a woman. So it's giving a probability of 0.22, which is fair enough. But look at that of a cat, it's 0.011. So you can see how great this model is. You can just feed in images together with some tests and check whether this image is an image of a person, is a dog, and this will return to you some probability. So what I'm trying to say here is that you can just save these embeddings into a vector database and then retrieve important chunks based on some text you enter. Okay, so let's say for instance you've saved these embeddings in a vector database and someone written a person, then means it's going to retrieve only files that have person in it. Okay, only images that have person in it. So it's fair enough that will work because at the end of the day to retrieve the ones with a higher probability before the ones with the lower probability, and this is going to make sense a lot. All right, so the final thing is that some of you will be having video files that you want to convert those video files into embeddings and not necessarily single images. So for that, I've also made provision for you guys, and I'm going to teach you how you can achieve that. Okay, so I think I'm going to comment all of this, and I have another script here. And what this script does is I go ahead, I'm importing OPCV and OS. So first I'm creating a folder in my directory, and this folder name is images. So you go ahead and check whether the folder already exists. If not, it will go ahead and create it. If it exists, it will just move on. Okay, so right after creating the folder, this function right here will take a video path. So when you have a video, you just have to give the path with that video to this particular function, and this will go ahead and read the video, check the frame rate, calculate the total number of frames per second in that particular video, and finally to go ahead and read that video and cut it into images. So you know every video is just a stack of images, so it will go ahead and separate this video into different images. It could be 100 image, it could be 50 image, based on how long the video file is. Okay, so it will just go ahead and separate this video into image files and save them into the folder we've created here, images. Then you can go ahead and read these images and convert them to embeddings. So the folder is not yet here, so I'll run it with you guys together, and this is the video I'm going to use. You can see this is the video, just people walking around. So we are going to call this function. Let me open that code once again. We are going to call this function, give it the name of this video. What is the name? video2.mp4. All we expect it to do is to go ahead and create a folder and separate this video file into images for us. So we are getting images from the video file, and I'll run this and let's see. Okay, so you can see the folder has been created, and it's went ahead to separate the video file into images for us. So we can explore the images before even converting them to embeddings. All right, so here are our images in the folder. You can see we have some number of them, about 12 images based on the length of the video. So these are some of the images it has given us. You can explore all of them. Okay, and I think it's fair enough. These images are good. Okay, so right after getting images from the video, now we come back to our code, and over here, this is the code we use to test it. Okay, I've written this code for you, which you to go ahead to read all these images, pass these images through the model, and then the model will create embeddings out of them. So first, what we are doing is that we are using glob. So glob is also one of the libraries we can use to read files in a certain directory. So we are importing glob, and over here we give the image path, which is right here, and you can see all these images are JPG. So you have to give the image path / asterisk, and then you give the extension of the images. Okay, so that's how the glob function works. I'm giving JPG, and this will go ahead and read all the JPG images as a list for me. So over here I'm just iterating through that list. Okay, the list of images, and I'm reading this image using the pillow library. Then we also went ahead to resize these images, and finally we are passing them through the function. So we are using the image function, and this will pass this image one after the other in the loop. And as I'm passing them, I'm also printing the embedding so that we can visualize whatever is going on. But in a real world scenario where you want to use this, as you are passing them through, you can be saving that embedding in a vector database. One vector database I would recommend you can use, which gives you some free tier online. You can save these embeddings online and use with it, is the PyCon vector database. So you can check it out, and if you want a tutorial on that too, you guys should just comment below, which I'll be much grateful to do it for you guys. Okay, so let's jump right in and run this code and see how everything will turn out. And here we go, guys. So you can see it's giving us the embedding one after the other. We have about 12 to 13 images, so it will do this for each and every image. Okay, so you can see how long it is, and we've gotten this embedding. So if you have a video file, this one hack you can use for it in order to get the embeddings from video files. Okay, so these also have some disadvantages, which I'll discuss in maybe some other videos, because we can lose some of the information since we are taking the information each second. We can lose some of the video frames, and but I think it also works great doing it like this. There are other methods you can use, which is beyond the scope of this particular video. So guys, happy exploring. I just wanted to explore the capabilities of this model because I think it has great capabilities that you guys can use this model in projects that will be helpful for you. So if you like this video, give me a thumbs up. Also, if you're not subscribed yet, make sure you subscribe, and up until then, I'll see you in other tutorials.